We're now starting Chapter 8, and we're looking at Section 8.1, where we're going to look at the sum of the angle measures in a polygon. For this problem, we need to use a formula that was given to you, which is n minus 2, sorry, having some troubles here. Let's try again. N minus 2 times 180, where n represents the number of sides, but it also represents the number of angles, because if you notice, this has 1, 2, 3, 4, 5, 6, 7, 8 sides. It also has 8 angles if you count around 1, 2, 3, 4, 5, 6, 7, and 8. So in this case, n is equal to 8. And what we're doing is we're finding the sum of the interior angles. That's why I use sum of interior. You can see it here. So n is equal to 8. We say 8 minus 2 times 180, and we get out our handy dandy calculator. That gives us 6 times 180. Calculating that, we get 0, 8, 1080 is our answer here. So again, we plug in 8 for n, and we have 8 minus 2 times 180, which is 6 times 180, which is 1080. Okay? That means that this angle plus 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 this angle equals 1080 degrees. Okay? Here's another one where we know the sum of the measure of the interior angles is 900. We want to classify the polygon by the number of sides. So remember, again, we know the sum of the interior angles equals n minus 2 times 180. Now if you notice, they gave us the sum of the interior angles as 900. So the 900 goes here. And that's equal to n minus 2 times 180. And in order to figure out the number of sides, you can multiply 180 by everything here, but what I would suggest doing, because it should be divisible, is to divide both sides by 180. If we do that, we get 900 divided by 180 is equal to 5. That's equal to n minus 2, and adding 2 to both sides, we get n equals 7, which means there are 7 sides. And if we were to classify this, remember a 7-sided figure is a heptagon. Make sure you know the names of all the polygons from 3 sides up to 10 sides, and then 12 sides as well. Okay, if you want me to go over those in class, or Mr. Liu to go over those in class, let us know. So again, we're going to use the polygon interior angles theorem, but we're going to use it backwards. We divide both sides by 180. We add 2 to both sides. We get a heptagon. Alright, and now here is an 11gon. Remember, 11 sides or anything over 12, we're just going to write the number and then a dash and then gon. You should know, again, a 3-sided figure, which is a triangle, up to a 10-sided figure, which is a decagon, and a 12-sided figure is a dodecagon. So we want to find in this problem the sum of the interior angles for an 11gon. This is our n here, because it's the number of sides, also the number of angles. So we say sum of interior angles equals where n is 11, so we say 11 minus 2 times 180. That's going to be the same as 9 times 180, and if we multiply that out, we get 0. Let's see, that's a 2, carry the 7, should be 1620. I hope that's right. I'm going to double check. That doesn't look right for some reason. 9 times 180. Nope, that's right. 1620. Okay, here's another one where they give us the sum of the interior angles is 1440. So again, what we do is we say 1440 is equal to n minus 2 times 180. We're going to divide both sides by 180. so that the 180s cancel, and 1440 divided by 180 is equal to 8. So we get 8 is equal to n minus 2. We're going to add 2 to both sides, and if we do that, n equals 10. We're to classify the polygon by the number of sides, so that would be a decagon. And that's it. Thanks.